right, well, welcome everyone to eRotary Coastal Club. We are at the January 21st, 2021 speakers meeting. And today we have Soupy Dalyander. She's a Ph.D. physical oceanographer with the Water Institute of the Gulf. And her presentation is going to be sea level rise, resilience in a complex system. And she's going to be discussing challenges and opportunities. Now, Soupy, if you wouldn't mind, as we do with all of our presenters, you are the fourth in a four presenter series on sea level rise. And so we've asked each of our presenters so far is just to basically give us a little bit of background on yourself, and then what got you interested in coastal issues, and then in this topic of sea level rise in particular, before you get into your presentation. And then I'll turn it over to you for the presentation. Thank you.
First off, Philip and Eric, thank you for the opportunity to speak today. I'm Soupy Dalyander. I'm with the Water Institute of the Gulf. Although I'll caveat now, part of the reason that there's some representation across Water Institute is I drew expertise across a number of people that are in the Water Institute, and number one, maybe they want to make sure that I don't screw anything up presenting some of the work that they've done and their expertise, but more importantly, that also has them in the pool for potential answer to questions that maybe not as strongly in my wheelhouse. So that's good, and I appreciate them joining for that reason too. So my background, I have had a fairly nonlinear path in terms of my education and work. I've always been in the sciences and engineering. My undergraduate was in physics and math. I have a master's in oceanography. And my master's and PhD is in mechanical engineering, fluid dynamics. And part of that is that, there are folks who really get interested in a particular problem or a particular topic and really want to dive into that. And for me, part of the allure of the sciences and engineering is the opportunity to do problem solving and solve complex puzzles that mean something to the world and it means something to people. And sea level rise is, in many ways, it's at the far end of the spectrum of being a very complex challenge, very complex, puzzle to have to unravel in terms of, thinking, about all the impacts and the uncertainty and how to manage that uncertainty in terms of, the impacts to the physical system, in terms of people, how to respond, how to be resilient in the face of that. And so really that's something, that's a major reason how I became interested in this topic. In terms of my specific area of expertise, I'm a physical oceanographer. I've done a lot of work in sandy systems, beaches, barrier islands, the shallow continental shelf. I do a lot of numerical modeling of sediment transport. But more and more in the past few years, particularly, I've gotten interested in being involved in bringing that in expertise to interdisciplinary studies that really focus on coastal restoration and what can we do to mitigate impacts of not just sea level rise but also storms, coastal erosion, etc. So that's kind of the context. I'll go ahead and jump into the presentation. So I mentioned to Philip before the call, one of the it's both a blessing and a challenge to come last in a sequence, especially when there's so many good speakers. And we've heard from Denise Reed, Jeff Carney, Alex Kolker. A lot of the pieces of that puzzle was sea level rise and some of the challenges. So the challenges associated with predicting sea level rise and the associated uncertainty, and then translating that knowledge and understanding into communicating that to people and being able to understand that human response, what the opportunities are, thinking about coastal resilience planning and how that's approached. Because bottom line, and I appreciate this was emphasized so heavily, in the last presentation, the coast is important to people all around the world and in different ways and in different usages. And then one of the things, and this is kind of, in large part very tied to and maybe motivating with the thread of this presentation, was in the discussion after the last webinar, There's a question about, students are interested in sea level rise. What, how do they get into this? How do they kind of like broach that topic? What's important? What do you study? And one thing that came out was the importance and ever increasing importance of interdisciplinary studying and be able to work with other people who have different areas of expertise. And that's kind of the thread that I want to kind of pull through this presentation, building on what we've heard from from the other previous presentations, to look kind of take a step back and look at the interactions between sea level rise drivers and impacts across the coastal system, which is very complex, and sort of take that challenge, of those complex interactions, to think about opportunities where that sort of interdisciplinary and broad way of approaching the challenge really is the kind of the where I think and where I think the community, the research community is heading, as far as a lot of opportunities. So I'm not going to spend a lot of time on this because Denise Reed did a really nice overview of sea level rise and uncertainty, but kind of putting it in the context of the Louisiana coast and the northern Gulf, and to set the stage for talking about this. The drivers of sea level rise, there's eustatic sea level rise, the water level increasing, sort of a global phenomena. You think about like glaciers melting and thermal expansion and the rising seas from those drivers. But combined with that, and of particular importance in Louisiana, of course, is subsidence and the lowering, for various reasons, the lowering of the land elevation. And these two factors, they both have considerable uncertainty related to what the actual outcomes are, when you're going to have certain relative sea levels compared to the coast. Um, but there's also it's very important to realize that although sea level rise is a global phenomena, the impacts of sea level rise and how that manifests in terms of different communities, in terms of different ecosystems, is a very local and regional phenomena. These two contributing forces result in differing relative sea level rises that vary, and therefore kind of the response and planning needs to vary. And what are those responses? And this is the whole kind of thread, the title of the talk. This the coast is a very complex, interconnected system, and so because of that, the impacts of sea level rise are complex, and there's a lot of cascading impacts that can happen here. So if you think of sea level rise, the very basic, if I were to tell one of my kids sea level rise, and you think about water getting higher, and there's some primary impacts of that in terms of flooding, in terms of the impacts of storms and storm surge. But there's that starts to cascade as you get flooding and increased water levels. You start to change the landscape itself in different ways. Coastal erosion, land loss, obviously very familiar in Louisiana. Then when you think of people's understanding of that, you think of ecosystem changes. So as the land itself, losing land as it's changing, you have essentially the foundation in which these ecosystems are sitting are changing, in addition to the direct impacts you can have from things like saltwater inundation. And then you have people, and that's the most complex interaction of all, because the direct impacts of flooding, the impacts of coastal erosion. You might be in a community that puts homes up on stilts, elevates them, to protect from flooding. But if the beach erodes out from underneath, that's still a loss. And the interaction between communities and the reliance on ecosystem services and fisheries, recreation, and so forth. And so I kind of want to step through each of those, and to kind of dig in a little bit more detail and present some work that my colleagues and others have done that sort of dig into that. And again, because this has been talked about in previous presentations, I don't want to spend a lot of time on this, but because it's so important in understanding this piece about the uncertainty associated with sea level rise. A little bit of difference in particularly relative sea level rise can make a big difference as far as the impacts that are felt, especially when you think about these complex interconnected systems, because there's so many feedbacks and so many tipping points. I'm going to talk about that a little bit as we go forward, where a little bit of change has a big impact in terms of the response in the system. And so, kind of walking through, starting at that simple level, that level that if I told my elementary school age kid, sea level is rising, they're going to be thinking about water level. Water level is higher. And so in terms of the impacts, this isn't, when you think about sea level rise, it's not necessarily a catastrophic acute disaster that people are maybe used to thinking about and used to being resilient to. It's sort of a gradual, slower process that can have a lot of impacts. So what you're seeing on the screen on the left is the number of flood events for Charleston Harbor in South Carolina from 1980 through 2018. And then the same thing is plotted as a bar plot on the right, but it shows basically classifying the flood events as being minor or moderate in orange and red, or major in purple. And what you can see really clearly is that the number of flooding events have increased, and a lot of that is due to minor or moderate flooding, so-called nuisance flooding, flooding during spring tide and king tide. And calling it nuisance flooding is maybe a bit of a misnomer, because when you think about the impacts that those type of flooding events have, that saltwater inundation causes damage to infrastructure. There's economic impacts, again, because this is a gradual disaster and not an acute disaster like a hurricane. Some of the response strategies and funding that might be available for that type of disaster is not something that necessarily is on the table with this. It's disruptive to lives. There's a community near to me that I live in St. Pete, Florida, that they have a lot of flooding during tidal events. And, there are kids that the school bus can't get through. And so they just miss school just for the simple reason that, during a king tide, the roadways might be flooded, a few inches of water and the school bus can't get through. So, these are major impacts in terms of people's lives. And of course, sea level rise does magnify the effects of acute events as well. So hurricanes. So the plot here on the left is hurricane water levels for 2015 contrasted to adding a little bit under a half a meter of sea level rise. And, it's not, in the case of storms, it's not just about raising the floor, on top the water level on which the storm surge rises. There's interactions, features such as the broad continental shelf that's present along the Louisiana and Texas coast can cause additional storm surge. You also get a lot of local variability, and people live locally. They don't live on a map this scale. It's all about what the impacts are to them, personally, to their house and their community. And so if you compare those two, the storm surge with and without sea level rise, the plot on the left is the difference. So basically, if I just took those two plots and took the difference between them, and what you can see is, offshore, the change in that storm surge is equal to the sea level rise, that little under half a meter. The plot in the bottom right, that direct impact of sea level rise has been removed. So where it's white offshore, that's because it's backed out the sea level rise contribution. And what you can see is that this isn't a uniform raising of the storm surge. There's these complex interactions result in regionally variant increases in storm surge. So when people are thinking about planning for and mitigating for this, they have to understand it on a local level, because again, that's the scale in which they're living. So, on top of sea level rise, like we were talking about at the beginning, this increase in water level, water is a very powerful force. And it, because of that, it has a lot of capacity to change the geophysical landscape, particularly because in coastal systems, most coastal systems live in a delicate balance with wave storms, storm surge. And so over on various timescales, sea level rise and even thinking about, oh, half a meter is not that much, or an uncertainty in a tens of centimeters might not be that much. It actually can. It does matter. So when you think on geologic timescales, for example, if you look, the type of system that we have, along the Louisiana coast with marshes surrounding basins and then barrier islands in front, you have a cascading series of impacts. So as sea level rises, The marshes that surround the basins can decline. You get an increase in the size of those basins. Now, that the folks can think about, if you have a basin that has more water and you're having to move that in and out through inlets and tidal exchanges, it tends to increase the size of the inlets. The barrier islands themselves, as the water level is increasing, tends to transgress or move toward shore. And eventually what you get is essentially system collapse, where the barrier islands start to drown, you get marsh loss. Obviously this is something that in Louisiana, folks that are familiar with the Louisiana coastline are very familiar with, because that sort of end stages are starting to be seen. And of course, those impacts, although they happen on geologic timescales, there's also shorter timescale impacts that can happen, and that are relevant to different kinds of barrier island systems and coastal systems. So this is Dauphin Island, Alabama. So this is a barrier island of a completely different origin and different characteristics than the Louisiana barriers. It's a little bit higher stand. But you can see, you can see the very dynamic nature of barrier islands, even just looking in, satellite imagery of the island on a large scale, between the 80s and more recently, where the combination of storms are a big driver for barrier islands, and sea level rise have driven major changes to this island. So in 1984, you can see the like a thin strip of beach fronting some vegetated areas. It's a coherent island. The island, I'm not sure if you can see my mouse, but the little island off to itself is Pelican Island in front. And as you move through, particularly as you hit the storms of the early 2000s, Ivan and Katrina, this island gets overwashed. So the ocean water levels and waves are high enough to sweep over the island. You have substantial vegetation loss. You have this 2 kilometer breach, the hole that shows up in the middle of the island. You can see Pelican Island over to the east end migrating significantly and eventually merging on. And you can see the impacts of people. So the in the center of Dauphin Island, where that hole opens up in 2006, you'll notice in 2016 it's closed with a line. That's not natural. That is where Army Corps of Engineer put in a rock wall to close the breach and to basically facilitate the sediment transport closing the breach. And so, when you think about this type of barrier island, and looking forward to how sea level rise is going to, continue to overlay on top of these systems, what you're seeing now on the screen, and it's not important necessarily to know the guts of this, but what this is running a numerical model, running a computer simulation, and looking out into the future, and basically changing a few key factors to look at how it would change the response of Dauphin Island. So as you go to the right, it's increasing sea level rise, and as you go down, it's increasing storminess. And these are on more of like a decadal kind of time scale, so a little bit shorter than that geologic time scale. And so, we're talking about sea level rise today. What you can think of is that each of those rows is one set of storms, of either not very many hurricanes moving up to some pretty frequent and catastrophic events like what happened in the 2000s. And then as you move from left to right, how does that same set of storms, how do the impacts change with increasing sea level rise? And what you can see is that, in that top row, if you don't have that many storms, the impacts of sea level rise are maybe not so acute. But when you get down into those higher storminess cases, you see major changes. You go from an island that is breached and is starting to be cut up by those by overwash and inundation and cuts through the island, to one that at the highest storminess and highest sea level is basically most of the island has been submerged. And the reason that happens is that barrier islands are very susceptible. The response is nonlinear with water levels. So as you start to get water levels that get above the crest of the dune, so if you go out to the beach and you have a nice sandy dune, once the water level gets higher than that, what you tend to get is what's called overwash, and you get inundation effects, and the whole dune tends to, the sediment is washed in the lee of the dune, lowers the elevation of the island. And so the main point there is that you kind of have this threshold where if you're below the threshold of the dune height, the impacts are not as bad as if you're above the dune height. And dunes in across the Gulf of Mexico, they vary, regionally. Louisiana has fairly low berms and dunes, but even at the, even high is only a couple of meters in the Gulf of Mexico. And so, when you start thinking about sea level rise and half a meter, and some uncertainty that might be in the tens of centimeters, the effects that you'll see on these barrier island systems, the response difference is pretty dramatic. So that's all thinking about the underlying system, right? The changes in water levels and the changes in the how the geophysical system responds. That also has impacts, ecological impacts, like mentioned at the beginning, not just direct, but also, these indirect effects, because all of those changes to the landforms upon which, habitats sit and species live impacts them very, substantially. So going back to that Dauphin Island plot, this is basically the same output from that model, only looking at habitat. And so the top plot is for a low sea level rise case and sort of moderate storminess in terms of hurricanes. And the lower plot is a high sea level rise scenario and high storminess. And what you can see is that even in areas where the land is still subaerial, so even when you're still above the level of the ocean, whereas for the upper plot, you see a lot of beach, dune, barrier flat is another sandy type habitat. As you go to that lower scenario, a lot of that, what was that habitat is now intertidal. So you've lost that dune, you've lost the habitat that the species that need that type of habitat would be able to utilize. And of course, that's true in Louisiana as well. So, that you have land loss. So the story that everyone knows that as far as as you get increasing relative sea level rise, you get land loss throughout the delta. But it's important to keep in mind that in addition to that, you get vegetation changes and the associated ecosystem changes. And so the plot here on the left is looking at the initial condition distribution of vegetation across various types, saline, brackish, fresh intermediate, marsh type environments, and then submerged aquatic vegetation. And depending on the sea level rise scenario, and again, highlighting the importance that uncertainty, having to be robust in planning despite that uncertainty in sea level rise, you get a significantly different distribution in terms of those vegetation types. The impacts to the ecosystems are pretty profound. Another example, this is some work most of Boston had done at Water Institute. This is one of the things that I think, I told you I'm a physical oceanographer, so I'm not as familiar with kind of the ecosystem change. And I think I had in my mind, thinking about wetlands and marsh and their impacts. But some of the habitat impacts and the ecosystem impacts, are maybe not intuitive to folks that don't have that specific expertise. So this is some work that was done in Lake Maurepas, and the little map shows where it is in the top left if you're not familiar with it. And it's showing the change in, I just pulled out a couple ecosystem, fresh forest and open water. And if you focus in on the yellow and blue line, because that's without restoration. So what's the system going to do naturally if nobody intervenes? And what you can see is the fresh forest acreage, over time collapse. The open water increases as you might expect, but you get that fall off in fresh forest. And that's the major driver of that is the relative sea level rise. That's what's causing that. The other thing that I wanted to point out is sort of starting to hint into that opportunities is that that there isn't there are things that we can do as people to mitigate some of these effects. And so in this case there's the other lines, the purple and red, are showing those changes with restoration, so with incorporation of Louisiana Coastal Master Plan projects. And you can see it's a substantial difference. And so with restoration, you can avoid hitting those tipping points where, for example, there that dramatic decrease in fresh forest. Kind of taking it one step further and revisiting, another complexity to this is that, if you think of things like marshes disappearing with sea level rise, this isn't a case where water level comes up, marsh suddenly disappears. The edge just marches back, and then you don't have any marsh anymore. The mechanism through which that happens is marsh fragmentation. And so as water levels rise, and you can see both the pictures kind of really vividly bringing that to life, and then underneath the conceptual diagram, the marsh itself will start to fragment, and you'll see increasing submerged aquatic vegetation before you get to that transition where you've moved from marsh to open water. And the reason, kind of the how marsh changes, in response to sea level rise matters, is because, marsh isn't just marsh; it's also, habitat for different critters. Um, so this is again some work that was done at this is Tim Crothers out of Water Institute, and I found this fascinating. I said I'm not a critter person, but when you think about the change in the marsh, not just being that there's less marsh, but that as you're fragmenting, you're getting more marsh edge. So in this case, for example, what they found, juvenile blue crab, the thing that they care about, what they want, is the marsh edge. And so as you get more marsh edge, as the marsh starts to fragment, you actually get this greater abundance of crab. And so it's a little bit counterintuitive, and you also have to keep in mind that as you get into that collapsed open water, the marsh edge is going to go away too. But it really, to me, it highlights how complex those interactions are, and how the impacts to species, you really have to kind of dig in and understand, the mechanism of change, and really understand what species are utilizing, because there are going to be impacts, but they're not necessarily going to be obvious ones. And then, related to that in ecosystems, and this is kind of the big feedback loop, that, to be honest, that I wasn't aware of until a couple of years ago. But this is some work that's been done looking at changes in wetlands in terms of, fresh, intermediate, dry, different types of wetlands. So, somebody like me, admittedly, this is not my expertise. You don't necessarily think about there being different vegetation and whatnot associated with these habitats. But the bottom line is there are different types of vegetation associated with these. And as it turns out, they have different potential in terms of soil carbon storage. So, when you think about sea level rise, climate change, carbon dioxide, the greenhouse gases being, tied to climate change and sea level rise. One of the mitigation strategies that is used is carbon sequestration. So, can more carbon be stored in the landscape, and as opposed to in the atmosphere? And so, what this got in, this work, was digging into, was that capacity varies with the type of wetland species, vegetation species you have. And so this is showing the change, fresh, intermediate, brackish, salient, change in vegetation type, wetland vegetation type, historically, so from 1949 to 2013. And kind of the important thing, with this, or the point I wanted to make in talking about sea level rise and complexity, is that as you're getting, as you're depending on the type, the salinity, and depending on the type of vegetation you have, and this is that plot on the left, the total carbon accumulation you have varies. And so with sea level rise, as you're getting changes in the types of vegetation you have, you're actually changing the amount of carbon storage that you have. And, again, carbon and the amount of carbon that's in the atmosphere versus the landscape is, related to climate change and the drivers of sea level rise. So again, it's complex. There's a lot of pieces to think about. And kind of the last thing, I wanted to hit on is, again, coastal communities. And there was a number of really good points made during the previous presentations. So I think this is something people have already been thinking about, on these webinars. But kind of drilling in and what that means in terms of research and understanding climate change, or excuse me, understanding sea level rise and understanding mitigation for that. One thing that I think is really important is thinking about coastal communities in terms of the people and in terms of the threats they face. And Scott Hemmerling, who's in Water Institute, has done a lot of work with this. This is something I hadn't necessarily thought of on this perspective either. People. It's not like as a person or as a community, sea level rise hit. It's hitting us, and we need to address it. It's in the context of having other challenges, hurricanes, droughts, pandemics, that are putting stress on communities. And so the community resilience in the face of sea level rise has to be thought of in the context of these other stressors. And in addition, this is so you can read the quote on the screen. What this came out of was going out in the communities and talking to members of the United Home Nation in Terrebonne Parish about flooding, sea level rise, talking about these impacts. And this is some really cool work that basically it's georeferencing narratives. This is probably not the words that the experts in this would use, but you get to take these stories and put them, on a map, georeference them, look at the actual change in the system and in flooding and some of the complex modeling that we can do on the science side, and then put it in the framework of how people are seeing and feeling those impacts and what concerns them. So, in this case, sea level rise isn't an abstract and the impacts aren't abstract. It changes, not only the physical system and the ecosystems and the people that, may rely on that, in terms of fishing and whatnot, but it's a cultural aspect too. There's a heritage piece here that needs to be thought about. People want their children and their grandchildren to be able to have the same experience and culture, and how do we preserve that despite the fact that sea level rise, status quo is not going to be an option with sea level rise. We have to figure out how to preserve these things and how to be resilient despite that. What's the answer? And I don't have it. That's the answer, is that there is no simple answer, of course. But I think the take home and what I felt hearing the other speakers and wanted to kind of pull through this was that integrated solutions are really the way to start to address the complex challenges, all those things that I was just talking about, of these complex interactions. That also kind of gives some hints of the best path forward. Scott's done a lot of work in community resilience and in looking in these interconnectivity. And you have to, from my perspective, you have to think about resilience, pulling all these things together. So what are the changes to the natural environment? What are the changes to ecosystems and to the ecosystem services that people rely on from those systems? How does that impact communities in terms of their economies? Different communities have different, the economic base is different in terms of how much they're relying on, fishing versus other, other industries. How much money do they have to be able to invest in different types of solutions? How resilient is that infrastructure and how does it then feed back? Because, I could put up a giant seawall and I might stop flooding, but if I destroy some of the ecosystems upon which, people, for example, tourism or, fishing that people rely on, that hasn't actually changed resilience. And then how does all that feed with the different roles that the government, the community leadership plays? How does that play with communities and how their social connections can make them more resilient? And really what all of that suggests is that, what we need to see and what we are seeing, more of, and Water Institute's been doing a lot of this, a lot of people have been advancing this, is that, what needs to happen is interdisciplinary work brings together scientists, brings together engineers, brings together people with expertise in the physical system, in the ecology, but also, social scientists, people that understand people, and that can bring the community members right into that discussion, that can, literally bring them to the table to be engaged in the research on sea level rise impacts and in potential solutions. And so kind of I didn't want to just leave that out there as a conceptual, idea, because, it's very easy to say, oh yeah, we should all work together and be integrated. But, what that looks like on the ground, we've got a project right now, working in Port Fourchon. And, this is looking at basically beneficial use of dredge material to put in marsh, wetland type areas. And, I've been doing this for about 20 years. And when I started, this would have been like an engineering, kind of approach. All right, we've got this amount of sediment. Where are we going to put it? Done and done. And that's still important. The engineering community and the expertise that is brought there is vital. But you start to see a progression where people think about, well, maybe we need to bring in more of the scientific community, the research community, because there are some things we don't know about how. It turns out some of those early projects that we built didn't respond the way we thought they would, and maybe now we need the scientific community to understand that. People started adding in, that you need the ecological piece and people that have that expertise to understand how, how systems will respond, how species will respond, because it turns out if you build it, they won't necessarily come. If you don't build it right, you might not get the benefit to some of the species that you wanted. And then kind of what's happening in the most recent sort of rounds of way this is approached, that I think is the way this is happening at Port Fourchon, is incorporating communities. So instead of us doing something, as being, researchers, scientists, engineers, and telling people, having a dialogue with them. So the first thing that we've done in the Port Fourchon project is go out and talk to the folks that have fish camps, the folks that live out there, work out there. What are you seeing? Where are these impacts? Where's the biggest bang for the buck? In terms of, you're out there on the water, what do you see? What do you think? And so, identifying areas, and that's what's shown in the plot. Where do you think, some of these restoration projects, might be best served, and then taking that knowledge and the knowledge they bring to the table and using that to design the numerical model frameworks, things that are actually going to analyze the benefits. And we benefit from their knowledge and their input, and it also is an opportunity to have a dialogue as these models are being constructed to explain how they work. And so that at the end, the community, it's not only has something that they could use, but that they feel comfortable with, that they understand enough that they will use it, and they will benefit from that, and that ultimately the projects themselves will have community benefit. So just kind of pulling it together, the knot on the end of that thread, trying to pull through this presentation, and everything that we've heard over the past 3 webinars. Sea level rise is complicated. It's the coastal systems are complex. The interaction between the physical system, between ecosystems, people, their reliance, economic reliance, community resilience. It's a big challenge. But the way forward, I think, is to increasingly bring people together, both in terms of expertise, interdisciplinary, research, scientists and engineers working together, but that direct incorporation of the community, and their knowledge and working with it, to be able to design, mitigation strategy, resilience strategies that work with nature and work with communities and work for communities, so that there's really a workable solution. So that's all I had. I'm really excited to get to be a part of one of these discussions again, because this has been I know the previous ones have been exciting. So